Hi guys, this is GIS and Remote Sensing Basic YouTube channel. If you're newly watching this channel, subscribe it for further videos. In my previous video, I have uploaded a groundwater potential zone mapping part 1. In that video, we have seen the basics of groundwater potential zone mapping and which are the layers are needed for groundwater potential zone mapping. So using that layers I have already prepared the lithology, soil drainage density, lineament density and slope. In this video we have to see the preparation of land use, land cover and geomorphology using the Landsat imagery. I have downloaded the Landsat imagery from Earth Explorer site. After that we go to see the groundwater potential zone mapping. So now I add the Landsat imagery bands for creating the false color composite. Here I select the 543 bands. See, these are all the 3 bands. Okay. For creating the false color composite, I am going to select the composite band options from the data management tool. Select the input raster is 543 bands. See, the FCC is created. Now I remove these bands. Using this false color composite, I am going to prepare first the land use, land cover. For land use, land cover and geomorphology preparation, I have used the NRSC classification, and I have already prepared the land use, land cover and geomorphology map using the NRSC classification and image interpretation techniques using interpretation keys. Okay, now I add first the land use, land cover of this area. See, this is the land use, land cover image, land cover, and I will show you the attribute table of this shapefile. See, these are all the land use, land cover features. Okay, I will show you in symbology. See, this is the land cover, land use, land cover. This color is not good, so I will change the color. See, this is the land use, land cover of this area. Here, this violet is the plantation area. See, this is the plantation area. So I have mapped in a plantation, and this green is the land without scrub. See, this is the land without scrub. Like that I have mapped all the areas using interpretation techniques. This green one is the tank. See, this is a tank, and this is the cropland, and this is fallow land. Okay, this is the beach. Sorry, sandy area and land without crab. This is the river. Then this is the mining area. So it is classified based on NRSC, National Remote Sensing Center, India. So after that I add the geomorphology map of this area. This one also prepared using the NRSC, National Remote Sensing Center classification. See, this is the geomorphology features. I am going to show you in a symbology. See, this is the geomorphology features. This violet is indicates the pediplane area, and yellow is the alluvial plain. Brown and light green is indicates older coastal plain and younger coastal plain respectively. See, this is the older coastal plain borders, and this is the alluvial plain between the river. Okay, next is beach. Sandy area is the beach, and this light pink color is indicates the mud flat area, and the green color is creek. Okay, this is the geomorphology of this area. Now you see the 7 layers are prepared. I am going to prepare the groundwater potential zone mapping using these 7 layers. For groundwater potential zone mapping, rank and weightage is very important. I have already prepared the rank and weightage table using analytical hierarchical process method. See, this is the rank and weightage table. Okay, I give the highest rank for the geomorphology because this is the first important. So I give 7 weightage, and lineament density 5, 6, 6, lithology is 5, slope is 4, and soil is 3, land use land cover is 2, and drainage density is 1. Okay, it is in a row. In column, you divide this in 7 divided by 1, 7 divided by 2, 7 divided by 3, 7 divided by 4, 7 divided by 5, 7 divided by 6, and 7 divided by 7. Likewise, you divide the all parameters by 1 to 7. See, like this. Okay, after that you want to find the overall weightages of this area, these parameters. You first add this geomorphology column. See, now I add this geomorphology column. See, 7 sorry 7 plus 7 divided by 2 plus 7 divided by 3 plus 7 divided by 4 plus 7 divided by 5 plus 7 divided by 6 plus 7 divided by 7, so it is 1. So our total is 18.15. Use this total value, you divide the individual values. For example, you divide 7 by 18.15. So see, 7 divided by 18.15. So the value is 0.838. So the geomorphology weightage is 0.38. Likewise, you divide 700 by 2. First, this is 3.5. So you divide 3.5 by 18.15. So this is 0.19. So the linear density weightage is 0.19. Likewise, you select the divide all the values, and linear density calculation also gives the same results for as per the geomorphology. Likewise, all the parameters give the same weightage. This total is 1. So AHP total is 1. So geomorphology, linear density weightages, and this is the lithology weightage. This is the slope weightage. This is the soil, and this is land use, and this is the drainage density. Okay, this is the second table. This is the geomorphology features. Geomorphology, and this is the geomorphology subcategories. Okay, see, the geomorphology weightage is 0.38. So I multiply it by 100. So this is 38. So geomorphology weightage is 38. Likewise, you multiply the all weightages into 100. So see, lineament is 19, and lithology is 12, slope is 10, soil is 8, levels is 6.6, and drainage density is 6.4. So next one is the rank. The rank is given by using the subcategories of geomorphology. For alluvial plain, I give the rank as 5. Because the alluvial plain is more important for groundwater potential zone mapping, so I give 5. Second one is beach. This is the lowest importance, so I give 1, and beach ridges 2. Depends of the groundwater potential zone importance, I give the rank for all the subcategories for all the layers. So next one is linear density. Linear density high area is most important, so I give the rank as 5. And very low is lowest important, so I give the rank as 1 for a very low linear density area. Okay, likewise I give the weight rank for all the features, all the layers. Slope is very low slope is highest weightage rank, and highest slope is lowest rank, and loamy soil is highest rank. Here you see the cropland and fallow land is the highest rank, and river is the highest rank, but the build-up land is very lowest rank. And drainage density very high area is lowest rank, because the high drainage density area have high runoff, so this is no groundwater potential. So very low is area is highest rank. So like this I have prepared the rank column. Now the next one is the overall weightage. The overall weightage is prepared using weightage into rank. So for geomorphology the weightage is 38, rank is 5 for alluvial plain, so I multiply it and the value is 190. Likewise you multiply all the weight and rank, and this is the overall weightages for all the layers. This is our final calculation. So using this overall weightages, we go to prepare the groundwater potential zone mapping. You want to type these values, overall weightage values, in the shapefile. For example, ground geomorphology alluvial plain weightage is overall weightage is 190. So I have typed in the shapefile. Here I am going to create one column. This is using add field. I am going to give the create the one add field. The field is weightage and type is double. Here we select here you type 190 for alluvial plain. And 38 for beach and 76 for beach ridges. Using field calculator you can type the values. Likewise you type the all values for geomorphology. Using these weightages we go to prepare the groundwater potential zone. The last one is younger coastal plain. This is 38. In this way you can type the all overall weightages values for every individual layers. You type the values in the shapefile. See, I have already typed the values for all layers. See, this is the land use land cover weightages. Slope weightages. This is lineament density weightages. And this is drainage density weightages. And this is soil weightages. And this is lithology weightages. Okay, this is not required, I remove it. Okay, we have typed all the weightages in a shapefile. So this 7 layer is most important for groundwater potential zone. So I am going to overlay this 7 layers using analysis tool option, analysis tool overlay option. Select the analysis tool, and that you select the overlay, and that you select union option. Using this union you can create the groundwater potential zone. Here you select all the 7 layers. geomorphology, land use, land cover, slope, lineament density, drainage density, soil and lithology. These 7 layers consist 7 weightages. So using these 7 weightages, we go to prepare the groundwater potential zone. Just give the OK here. It's take little bit time. Okay, the union is completed. So this is our groundwater potential zone area. Sorry, output, groundwater potential zone output. Okay, you don't confuse with this. Just open the attribute table. It is consist 7 weightages in single shapefile. See, this is the first weightage, second weightage, third weightage, fourth one, fifth one, sixth one, and last one, seventh. So using this, you can add the overall weightage by creating an add field. Create a field in name of overall weightage in the type of double format. In this overall weightage, you right click on it and select the field calculator and add the all weightages in this column. So this is the first weightage and plus it by clicking on this plus symbol and select the weightages for second weightage and plus third plus fourth plus fifth plus sixth plus seventh. You have two options. You just add it. Otherwise, you can take the average divide by 7. But it is not required here. So I'm not going to do that. I just add this 7 weightages. Okay, it is adding. Okay, see, this is the output. You select the start ascending option for seeing the lowest value. So lowest value is 6.6 and highest value is 446.6. So now you can select the properties and select the quantiles here. Add value in the value field. You select the overall weightages. See, it is classified into the 5 classes. You can select the classes, depends upon your need. Here the blue one is the highest groundwater potential zone area and light blue is blue is the very high groundwater potential and light blue is the high and green is the moderate, yellow is the low and red is the very low area. You can change the class intervals here also in the classify option. I give outline width as 0 for better view. Okay, now I give the OK here. See, this is our groundwater potential zone map, but it shows very high area in half of our study area. We go to specify our very high area by classify the overall weightage. You select the classify option here and reduce the very high area and high area, moderate area and low area by dragging these lines. If now you see the areas are changed. Okay, this is our groundwater potential zone map. You can convert this into the shapefile also by clicking the reclassify option and converting raster to polygon option. Okay, thank you for watching. Subscribe and share for more videos. Thank you.